one unfortunate thing for the applied part of this grade 11 is that we don't do this first two sections of this chapter before we do the sign law, which I think would probably have helped a lot more had we seen it before we did the sign law in the applied course. Okay, so they basically join up. In the applied course, we did sign, and then we did the law of signs, and then they join up here and then we did the ambiguous triangles, and now we just go straight into it. Okay, so first of all, if we don't have a right triangle, and I've got A, B, and C here, the first thing we have to remember is that the sides and angle ratios are all the same. So that's how we end up with this sign law. And I could flip these all as well. If I was looking for the angle, I could flip them all. And when I also look for the angle, I also have to remember that I have to use the second function of this. Now, the ambiguous triangles, all right, let's review what happens here. The first thing I do, I will be given this angle, I will be given this side and this side here. So I'm going to use them. I'm just going to switch, actually. Let me switch these out. Just to make it the exact same as what we did in, so this would be B here. C there, B here, C here, green pen, B here. Those are what I'm given. All right, so you're going to be given the following information. You'll be given this angle A. You'll be given the length of side A and the length of side B. And your job is to determine whether or not I have 1, 2, or no triangles. So the first thing that you find using right triangle trig is the height. So I find H, so I go the sine of A is equal to H over whatever B is. So H is equal to B times sine A. All right, so that's the first thing that we do. You remember this? Okay. Now, based on that information and what the length of side A is, I can determine whether or not I have 0, 1, or 2 triangles. If A is less than H, how many triangles do I have? 0. Because this length of this side right here, if it's smaller than H, it can't touch. It'll be hanging short of it. So there's 0 triangles. If A is equal to H, so if this side length is the same as H, I have one triangle. Now, if A is larger than H and less than B, so if A is larger than this and smaller than that, I'm going to end up with 2 triangles. Bless you. Okay, that's all given to you on page 81. And again, I do reiterate this, that this is for an acute triangle, meaning that there are not any angles larger than 90 degrees on it. Okay?
If A is bigger than H and also bigger than B, then there's only 1, right?
That's right. Okay? Because it's obtuse then. You have an obtuse angle. All right. So let's look at an example, and let's follow the example all the way through. I want to make sure I got this one that has 2 on it. All right, well, let's go through. Let's go through this example then. Given the triangle ABC, in which A is 42 degrees, C is 55 degrees, and B we need to know. All right, so the angles in a triangle sum to, bad English, but add up to what? 180 degrees. So if I take 180 degrees and I subtract 42 and subtract 55, I'll get angle B. What is the measure of angle B?
$83.
83. Okay. Now, I want to find the length of side B. So I go B over the sine of 83 degrees is equal to, what's the other side that I'm given? 8.3. And what's the angle across from the 8.3? Sine 55 degrees. So let's calculate what B is. Get 10? All right, again, we want to work through decimal places. Is it 10 exactly?
No, 10.057.
Thank you. 10.05, oh, that's not degrees. 10.057. Okay? And if I was, excuse me, if I was asked for A over sine 42 degrees is equal to 8.3 over sine 55 degrees. And let's find out what A is. So sine 42 times 8.3 divided by sine 55. Okay. 0? Yeah. All right. What's the first thing I look for to make sure that I have this probably correct or not?
The longest side is opposite the largest angle.
Right. Okay, and what was the largest angle?
83.
83. And is the side across from it the largest one?
Yes.
Yeah. Okay, so we're probably in a pretty good shape then if that happens, right? Yeah. Okay. I don't think it's necessary to do example B. It's the same thing. All right, let's have a look at 83. Working example 3A. Okay, yeah.
I got 26.
For
B.
this guy?
No, I mean A.
This guy?
The second one.
Okay, so you go sine 42 times 8.3 divided by sine 55. Did you get it right this time?
Yeah.
Okay. Now that could happen too if our calculator's not in the right mode. Remember, we have to have it in degrees. All right? All right, so let's look at triangle ABC. So let's draw it out. A, B, C. Angle A is 60 degrees. Side A is 14.
Yeah.
And side B is
15.
15. So what's the first thing I need to do?
Height.
Height. So let's find our height first. So our height is equal to sine 60 times 15. Okay. What's the sine of 60?
1 over 2 over 1. 1 over 2.
Square root 3 over 2. That's right. Okay, so what did you get? 12.990? All right. 14 larger than that?
Yes.
Yeah. Is 14 less than 15? Yes. How many triangles am I talking?
2.
2. All right, let's do both of these triangles now. So triangle number 1 looks like this. And I want to find all information based on the triangle. So the first thing I'm going to find is sine B. Okay? So I've got sine B over 15 is equal to sine 60 over 14. Okay? So let's find B first. Need angle B. 68.107 degrees. Everybody get that? Again, you have to use second function sine on your calculator. Inverse sine has to be used on your calculator. Everybody's got it? You may not get it, so I can check your calculator work.
Mine's an error. Sometimes you have to get some stuff in brackets.
So are most of my brains.
Oh, yeah.
Sine and the bracket. Now go 15 times sine 60.
Oops, error.
No, sine 60.
Oh.
Me too,
Your
bro.
calculator
Bye-bye.
does not want to cooperate.
Brain error.
Bracket.
There we go.
Get it? Everybody's okay?
As long as I use my. This one just puts everything on What?
You're like,
Okay, yours opens up a bracket automatically.
Okay.
When you do the second function sine, you have to close the bracket on the 60. So it's 15 times sine 60, close bracket, divide by 14 and close the second bracket that was opened up.
Okay.
Okay? All right, so what does that make C now?
51.893.
51.893 degrees. All right, and then that, now that we know what C is, we can find out what little c is.
68 or 12.72.
12.72. Okay. So there's my first triangle. That's triangle number 1. Triangle number 2. All right. How do I get angle B in triangle number 2 now?
Subtract the first angle from 180.
I need to take this right here, and I have to subtract it from 180. So I go, to get angle B, I go 180 degrees minus 68.107 degrees, and that equals 9.893. So there's my angle. That's my obtuse angle. That's the catch in the whole question. Because if you did the sine law again for that triangle, you'd still end up with 68.107. But when you take the sine of 68.107 and the sine of 111.893, okay, you're going to get the same ratio. So now that makes C what? What's angle C?
Uh, 8.107.
8.107 degrees. And I get that by taking 180, subtract 60, subtract 111. Okay? And then I have to find C. So to get C after, what does little c equal?
2.27, 2.280.
All right. Okay?
Can you just explain why you take the angle you found away from 180?
Yep.
For the second triangle?
Yep. What is that?
That's all we said, right?
Mm-hmm. It's 1/2. Okay. Now I'm going to get into this in greater detail in about 38 seconds. But here's what you need to know. That's a reference angle right here of 30 degrees, right? When I go over here, and if this is the reference angle is 30 degrees, that makes that angle right there 150 degrees. And I know that both those angles have the same ratio. The sine of 150 is 1/2, the cos of 150 is 1/2. And I find it by taking 180, subtract that angle, the acute angle. And I do that every single time, and I end up with the same ratio every single time.
Oh,
Okay? So in that last question, when I did this, I got sine 68.107. I subtracted from 180 and I get 111.893. They'll give you the same sine ratio.
oh, and that's why you got it.
That's why it happens. Okay? All right? Okay, now, this next piece. What I suggest you do is take a piece of paper out. All right. Draw that circle on a blank piece of paper. Put it on a blank piece of paper and draw it fairly large. There's a lot of information that's going to go on this. It doesn't have to be pretty. I'm going to give you a pretty one after. But right now I want you just to make sure there's lots of room though. Doesn't have to be nice, I'll give you a new one, but I need you to have lots of room to write down the information I'm about to give you.
Oh, are these like all the angles and stuff?
Mhm.
Oh, Rex taught us about, or told us.
Okay, so, first things first. First angle we're concerned with is 30 degrees. At 30 degrees, the cos ratio, again, remember, cos is x, sine is y. The cos of 30 degrees is root 3 over 2. The sine of 30 degrees is 1/2. $150 degrees. Actually, I should have started different. Anyways. The ratios are the same. Only thing that switches here is your sines. the x value is negative in that quadrant. Again, for all of these, my reference angle is 30 degrees. So for 210, my reference angle is still 30. My ratios stay the same. I just have them both as negative in that quadrant. So anytime the reference angle is 30 degrees, the sine is going to be, the y value is going to be a half, positive or negative. The cos is going to be root 3 over 2, positive or negative, depending on which quadrant you're talking about. Okay? Questions about that?
Can you write the little, like, that saying you had, cast?
Ask.
Yeah.
Okay. I'm going to do it red colors. All right, so far? Any questions about the 30-degree reference angle? Okay. Now I'm going to go to the 60-degree reference angle. Now the ratios are switched. Because the cos of 60 is a half now. And the sine of 60 is root 3 over 2.
So you're listing the cos first and then the sine?
It's cos is, what you learned was cos theta is x over r, and sine theta is y over r. And this circle of r is 1, so that means cos theta is x, and sine theta is y. Okay? Next one. 120 degrees, negative 1/2, and root 3 over 2. Again, the reference angle is still 60. Reference angle is always made with the x-axis. (240 degrees), negative 1/2, negative root 3 over 2. Both negative in that quadrant. What's the angle in this quadrant down here? What is it?
300?
300. So 1/2 and negative root 3 over 2. So those are all the 30-degree angles. Depending on whether the reference angle is 30 or 60, you just switch your x and your y. Now, again, what you need to do, so this looks like a lot of information, right? But all you need to know is 1, what's the reference angle? And 2, okay, which quadrant's it in for positive, negative. All right? But the third and most important thing you have to remember, the sine of 30 degrees is 1/2. So you should never get these switched. You know that the y value of 30 degrees is 1/2. And then it just follows the pattern all the way through. Okay. Any questions on your 30, 60, 90?
So sine is always y-axis, and cos is always x.
That's what I just said to him, right? So, yeah, so sine is y over your radius, in this case 1. Cos is x over your radius, which is 1. Now, let me show you. Don't write this down, but let me show you why that happens so that you all understand, okay? So I have this here. That's x, that's y. My angle is theta. My radius is r. Now, in the circle I just drew for you, your radius is 1. For this one, I'm just putting it as r. All right. This side, y. This side, x. Because that's my x and my y. Right? I go x units this way, y units that way. Okay? Sine theta is y over r. Cos theta, x over r. Tan theta, we don't do much with this yet, is y over x. So if I were, like, r is 1, that means that sine theta is y. Cos theta is x, right? So if sine theta is y, I could put it right here. Sine theta. X, cos theta. Tan can also be this. If you're ever unsure about tan, that's all you do. Take your y value over your x value. Okay? Now, let's go back. Now we're going to switch it up a bit. All right? I should have done this first, so I'm going to do it right now. Okay? 0 degrees. What's the coordinate for 0 degrees? This is the unit circle and the radius is 1. What is that coordinate? 1, 0. 90 degrees. What's the coordinate here? 0, 1. 180 degrees? Minus 1 and 0. And down here, 270. 270 degrees. 0, negative 1. Okay? Now if you punch into your calculator right now, the sine of 270 degrees. Sine of 270 degrees. Punch it into your calculator. What do you get? Negative 1. That's right. What about the cos of 180 degrees? Negative 1. All right? All I'm doing is giving you ratios that are not as decimals anymore. Now the halves, they'll make sense. Sine 30 a half, cos 60 a half. It'll be 0.5 on your calculator, right? Well, what you don't know is that sine 30, or you do now, but sine 30 is root 3 over 2. It gives it to you as a long decimal. That decimal is the same thing as if I took root 3 and divided by 2. Same thing. Okay? Now the last one we have to do is our 45s. And this should be the easy one, but for some reason it's not. If you remember from that triangle, the sine of 45 and the cos of 45 are the same thing. They're both root 2 over 2. Same thing here. 135 degrees, negative root 2 over 2, and root 2 over 2. Down here, 225 degrees, negative root 2 over 2, negative root 2 over 2. Down here, 315 degrees, root 2 over 2, and negative root 2 over 2. Et voila. Looks like a lot, doesn't it?
Sir.
If you look at it like that, it looks like a lot. But where did we start? On a blank sheet of paper. Blank sheet. Now, do we need to know, and we start, yeah, you're right, we started at 30 degrees. And what do? We went 30, 60, 90, 120, 150, 180. Okay, and it all depends on your reference angle. So, for you in grade 11, it's best just to see this, bless you. If you can apply it a little bit, that's great. But when I do this next year in grade 12, we got to hammer it out. We need to know it. But it's not that complicated. The only thing we do add is we add radian measures in there. But you'll find out that there's not much to that either. All right? For right now, I want you to see this. Because when you look back at 2.2, it was asking you some of these things. If you actually looked at the skill organizer on page 80, that's kind of what it was doing. It was asking you to find out ratios from the given points. Okay? So you have the remainder today to get started on 2.3. I want that looked at today. That's just law of science.
Yeah, I know this is the best of the class to read on.
Yeah, I think I did.
You did.
So I'll get those clear. Okay, any other questions today?
So today is basically just the sign law, which is basically what we did already.
Exactly.
Okay.
Basically exactly that.
Awesome.
Okay, so the next one after the sign law is coast law.
Say actually, let's do it.
Okay, so that's all there is for you guys today, and tomorrow we'll be working on the law of coast signs.